So today, we're going to be talking about thermoregulation. Thermoregulation is important for organisms to maintain their ideal body temperature. This regulation is conducted through heat transfer. Heat is transferred in 4 different ways. You have conduction, which is the touching of 2 objects, convection, which is fluid movement, evaporation, where liquids phase change to gases, and radiation, which involves electromagnetic waves. The temperature of an object is directly proportional to the kinetic energy of the molecules that compose it. Likewise, the kinetic energy of a molecule increases along with the velocity of the molecule. Therefore, the faster the molecules are moving, the hotter the object is. Let's take a look at the first form of heat transfer, conduction. Were you ever carelessly cooking? When you accidentally touched a hot pot on the stove, it burns, right? Let's look at what's happening from a molecular level. Let's say that all these dancing people are molecules of one object. The DJ is another object, and he's the heat source. As the DJ changes the song from a slow, or a cold song, into a fast, or hot song, the people closest to the DJ will begin to dance faster and become hotter. These people will begin to bump into nearby people, passing on this dancing energy, eventually heating up the entire object. Thus, heat spreads very quickly in conduction. If 2 blocks with different temperatures come into contact, the hot object will transfer some of its heat to the colder object until they reach the same temperature. Here's a little memory tool. Conduction sounds like a conductor, and conductors wave their hands in the air. Hands are used to touch objects, and thus, conduction involves 2 objects touching. Now, let's look at the second form of heat transfer, convection. Do you remember those hot summer days when you would use a fan to cool yourself down? That's convection. While conduction occurs in all phases, convection only deals with fluids like liquids or gases. Alright, so let's take a look at an example. Imagine an ice cream truck is giving out free ice cream. Of course you're going to have a huge crowd of people wanting some ice cream. The ice cream truck is the heat source and the people are the molecules. After this guy receives his ice cream, he's going to move to the back of the group because he's already gotten his ice cream. This is exactly what happens in convection. As the massive molecules of the fluid closest to the heat source are heated, it becomes less dense and becomes more buoyant, making it float upwards. This makes room for another mass of molecules. Each time a mass of molecules is heated, heat is lost from the heat source and is transferred to the fluid, just like the ice cream. In this diagram, as the fluid moves across the top of the heat source, this mass of molecules will become heated, less dense, and more buoyant, floating to the top. Then, a new mass of molecules will encounter the heat source and become heated in the same way. Here's a memory tool. When you hear convection, think of vents. This will help you think of convection as heat transfer through fluid movements like air. The third form of heat transfer is evaporation. Evaporation is the phase transition from a liquid state to a gas state. Let's say you're a kid and you're riding your bike along the park. At a slower pace and a lower energy level, like a cold liquid, the spokes of the wheels are clearly visible. However, if you eat some candy to raise your energy level, now you're like a hot gas, and you begin to pedal so fast that the spokes of the wheels are no longer visible. This is similar to a visible liquid vaporizing into a gas that's invisible to the naked eye. Evaporation occurs constantly with sweat or wet skin. Our warm skin heats the water, aiding in the water's transition from a liquid state to a gas state. Here's a memory tool. Evaporation has vapor in it, so when you hear evaporation, think of heat transfer through vaporization of liquids turning into gases. The fourth and last form of heat transfer is radiation. In radiation, all phases participate in heat transfer. Radiation is an emission of heat through electromagnetic waves. Every object in this world emits heat in this fashion. You probably already know the sun does, and batteries also release heat. Even you're releasing heat right now in these electromagnetic waves too. All of these objects emit energy in the form of waves. As their electromagnetic waves contact other molecules, it increases that molecule's energy and thus makes it hotter. Here's a little memory tool. Radiation kinda sounds like ray, just like the rays from the sun. So when you hear radiation, think of heat transfer in the form of these waves. And those are the 4 forms of heat transfer, made easy.